Okay, so you sent me the email, and you were asking about molarity in solutions. And I think part of that is because when you see the word molarity, you just kind of go, huh, molarity. And not mentally converting it into what it really is, which is just the amount of moles and over divided by per as a ratio the amount of liquid or solution that it's in, right, as a volume. So I've already written all this out. I've deleted it. I'm just going to undelete it in order. So molarity, right? We know that uh, molarity is really just the number of moles per liter of solution, right? And we represent it with that italicized M. Um, it's just a ratio. So given that, we want to take what we know, and we've said it's 20.0 grams of, I believe that's Ki, not Kl. So I'll assume that's potassium iodide per 100 milliliters of water, right? So I want to set up a ratio, a fraction that resembles what I want, which is moles per liter. Now, in this case, I've got the amount of stuff on the top, particles, molecules, whatever, and the amount of liquid on the bottom, right? So, if I turn what I have into a fraction, I want to keep it that way, right? For simplicity's sake. So I'm putting the grams, the stuff on top, and I'm putting the milliliters, the volume of liquid, on the bottom. Now, pretty obviously, if I look at my units here, I don't want grams, I want moles. And I don't want milliliters, I want liters, right? So I need to figure out a way to get from grams to moles and from milliliters to liters. Well, grams to moles is pretty obvious. We already know this. We know that we can look at the atomic mass of all the different atoms that make up a compound, like potassium iodide, and we can add them up, right? So let's go ahead and do that. Turns out, according to the periodic table I've got, the mass of potassium is 39.0983 grams, and the mass of iodine is 126.9044 grams. I actually had a little bit more information for the iodine, but I went ahead and truncated it. I cut it short. I know that my final product is not going to go to this many significant digits, so I'm allowing myself to be a little lazy. Technically, I shouldn't do that, but I think we'll get away with it in this case. That means my final mass of potassium iodine as a molecule, as a compound, is 166.0027 grams. Okay, so that means that my molar mass is the same, right? The molar mass of potassium iodide is 166.0027 grams. Nice. All right, well, what about, let's scroll down here. I also know that I've got, for every liter of something, I have 1,000 milliliters of something. I don't even really need to say water in this case. That's just a plain old unit conversion. It's always true, no matter what the liquid is. So 1 liter is equal to 1,000 milliliters. All right. So now we've got two equivalencies. I have grams, I want moles. I have grams, I want moles. I have milliliters, I want liters. I have milliliters, and I want liters. Now I can turn these equivalencies, these saying this is equal to that, into ratios, right? So let's start out with my initial ratio, which is what I was given, grams of potassium per milliliters of water, right? And now I can start multiplying by these guys, the moles per gram and the liters per milliliter, and I will just put uh, whatever I want in the denominator, so I'm canceling what I want to get rid of. Well, I want to get rid of grams, and I want to be left with moles, so there we go. So if I write it as moles over grams, the grams on the bottom will cancel the grams on the top. Grams in denominator will cancel the ones in the numerator. I am still left with milliliters here, though, which isn't quite good enough. So here we go. Now I've got 1,000 milliliters on the top, cancels milliliters on the bottom, and I'm left with 1 liter on the bottom. So we can see here the only units that are remaining are the ones I want, moles per liter, molarity. So if we actually go ahead and do the math, we're going to end up with this. Now, do we actually have to do this? No, you probably are looking at this right now and going, well, yeah, come on, can't I just say 1,000 divided by 100 leaves me with 10 on top, times 20 is 200. Do I really have to multiply it all out? No, I'm just trying to show all the steps. In any case, regardless of how much you simplify before you actually plug in the numbers, you end up with this monstrosity, right? That is how many, that's our molarity, the moles per liter of our potassium iodide in this case. Now, do we actually know it to God, like the millionth decimal place, trillionth, billionth, whatever? No, no, naturally not. This is just what the calculator said. And actually, this is the whole point of significant figures, right? If I were to record this number, it would imply that I was phenomenally precise in my measurements, that I'm absolutely certain that this is exactly how many moles there are per liter, which would be a big filthy lie. So I need to go back and we need to look at significant digits, right? And just real quick, all of our digits are written for us right here in this version of the equation. I know the 1 mole of potassium iodide, that is not significant digits. That's not a measurement. Only measurements have significance, right? This is just a plain old integer, right? It's a ratio. We know that 1 mole is equal to this many grams. Ditto for the 1,000 to milliliters per liter, right? That's a unit conversion. That's not a measurement. So these are my measurements, right? 20.0 and 100.0. I know I'm going to have to go with the lesser of the two because I'm multiplying or dividing. Ignore the dog barking in the background. And then, so I can't pause this video. All right, almost done. So I'm going to truncate this to the 4 digits, right? Leaving with my 3, see if I need to round up. Now in this case, the 4, the last one before it becomes significant, is not significant. And it's not big enough to round up the next significant one. So I end up just plain old dropping it. And we are left with 1.20 molarity potassium iodide. That assumes that all the numbers we got in the beginning here are correct. But hopefully that helps.